Hey, hello everyone. Everyone hear me?
Yes, very clear.
Okay. All right, great. So hope everyone had a great weekend, Labor Day weekend. I heard it's super hot in California, but but in Texas it's okay. And if you guys are in Austin, there's this week is Developer Week Austin. So we will it's a conference in the Palmer's Conference Center, and I'm gonna have a talk there. I think it's tomorrow afternoon. But in general, there's just I think a lot of developer activities. So we do have some free tickets. So I've sent that link in the chat in a minute. After I'm done talking. So, but so there's things going on here in Austin. Um, but that's not that important. So there's two topics that we want to cover today, and the first one is as you guys probably have seen in our in our GitHub activities that we have just recently released WasmEdge 0.11. That's I think a significant release there that contains some breaking changes to the API, and it's also ahead of the schedule. That's because there's some we wanted to release it later this year, but there are some real world application use cases that really requires some of the changes that we made in the 0.11 release. So the first agenda item in this meeting is for Haidai to give us an overview of the new features and what has changed in the new release of WasmEdge. So Haidai, please go on.
Okay, great. So today I'm going to do a quick review of that point one, the release. So actually we have do a deprecation of these two Docker image, which is the Maintainers 1 and the Maintainers 2010, because of these two Docker image are based on a very legacy operating system, which is the CentOS 5 and CentOS 6. And so they are not maintained anymore, so we decide to drop these two environment support. So please notice that if you want to use the most compatible version of the WasmEdge, please try the Maintainers 2014, the version. Okay. And in this release, actually, I believe we do four significant changes. So the first thing is that before this version, actually, we cannot provide an mechanism for the host function developer, so they can only return the arrow defined by WasmEdge. So in most of our use cases, actually they have lots of arrow code defined by themselves. However, it's no way to return them. So in this version, we extend the current arrow code mechanism, make the host functions can return the user-defined arrow code. And the second one is that before this version, the host function actually have the argument, which is called the memory instance. You can access the current executor memory. However, if you want to interact with the module instance or multiple multiple memory instance, there's no way, because we only provide the index 0 memory in this case. So we also designed to extend the original mechanism from the memory instance to a coding frame. A coding frame will contain executor, the current module instance, and all of the memory instance used in this module. So if you enable the multi-memory proposal, you can specify the index to access the corresponding memories. And the third one is that we decide to standardize the soul name and soul version of our C API. Before this version, actually, we do not use the soul name. So if we don't provide the soul name, actually, every time when we do a breaking change in our C API, our user have no way to know that, because when they use the DL open, then it just segmentation fault, or you will find that the symbol is not found. It will produce lots of the confusion for our developers. So after this release, we decide to to use the soul name and soul version. So now the initial version is that the 0.0. Okay, and once we have breaking changes in our our C API, the version, for example, this version may be go to the 1. If we just add a new APIs, the minor version will just increase by 1. If there is any bug fix, however, it is not related to the interface, we will increase the patch number. Okay, so this is the third key features here. And also, we actually expose more and more helper functions in our C API. I will mention them in the following slides. So there is some new functions in our C API. The first one is that actually in WASI, if you want to you want to open a file, or you open a socket, actually we don't we don't just use the real file descriptor in your the communications. Actually, all of the file descriptor and the handler will use a map to map the real number to a virtual number, and all of the WASI function will use the virtual number to do the communication. However, in some cases, our developer in the when they want to do something special in the host function, they will need the native handler, the native file descriptor. So we we provide this function. It can make the user can use the virtual file descriptor to get the native one. Okay, and the second new function is that actually our original interface only provides the user can compile a WASM file from a path. You can only give the path. You cannot give the buffer. So actually in some of the situation, actually we will load the WASM binary from the file first, and we will store it into the memory, and we will use it from the memory directory. We do not load from the path every time. So this function is to help our developers to leverage the memory usage more efficiently. Okay, then let's talking about the first important coding frame. So just I mentioned that the coding frame will contain at least three things. The first one is the current executor, the module instance, and all of the memory instance. And also because this coding frame is replace the original memory instance, so you can find that when you want to implement your host function or the rep function, and the first parameter of that, the type is changed to the calling frame context. Before it should be the the memory instance context. However, now it's changed. So please be careful if you are you are using some of the host function. Please just change the first arguments. Okay. And the second important thing is that the user-defined arrow. So actually, we extend the current WasmEdge result. Actually, the original size, I believe, is the unsigned integer 8. Okay, and we just extend it to the 32-bit integer. So you will become more larger space, and we have split this 32-bit into A plus 24, because the first 8 bits we will use it to represent the category. For example, this error is generated from the user define or is generated from our runtime. We will use the first 8 bit to do the presentation of the category, and the remaining part will be the directory error code. So you will have the enough space to store your error code. Okay. And also we do lots of changes because we find that some of the extinct APIs actually they should be used with the const qualifier. And before this version, we forgot to do that. So you will be you will be more danger if you do some if you modify it in your host function, and they maybe create some undefined behavior. So to prevent that situation, we just apply the const qualify to to avoid those situations. And also just naming style, and our previous version actually this is not not fit our naming style, so you just rename it. So if you use the C API and you load the plugin with this function, just need to rename it. So then the third one is the soul name. Yeah, the soul name is that if you grab the soul name, it will be the lib WasmEdge.so point dot 0. Okay, and if you want to the full version, it will be 0.0.0. Okay, and also because lots of people actually talk to me that why our library name will have this this underline with C. Actually, before in our original design, we will have the C API and the C++ API. So to to identify these two versions, actually we use these postfix to to identify that. However, in our current milestone, we will only provide the C API until we have enough engineering power to to create the C++ API. So we just remove this postfix. So now the name will change to the WasmEdge directory. So if you use the link flag, please make sure you remove the underline C. Yeah, so that's all of this soul name part. And we do have some changes in our CMake options, because that our Mac OS users that they don't want to install the LLVM by the homebrew, because you will just just pollute their environment or something. They want us to provide the pre-built binary, pre-built release assets with the built-in LLVM. So we create this option called the WasmEdge link LLVM static. With this option, actually the LLVM will statically linked into our the WasmEdge share library, also our tool. So when this flag is on, then on the Mac OS or on the Linux, we will just link the LVM inside of the WasmEdge. So you don't need to install the LVM by yourself. Okay. Then we do lots of bug fix. Thanks for lots of people report to us. So the first thing is that actually we someone when trying to embed it our C API, he found that when we enable the debug mode or the release mode, if you find that when we want to load a binary, they will get the different results. So the first thing is that we just just fix the error when the behavior is different from the debug mode and the release mode. Also, actually, this is a significant change in the multi-memory proposal, because the proposal have some typo. So the ordering of the memory argument and memory instance should be memory index and memory argument should be exchanged. The order should be exchanged. So in this version, we just made the ordering to be the correct one. And thanks to lots of people's report, we figure out and just an implementation error in our shift operand. And also thanks for those people want to port in our system to non ARM or non x86 platform. So they will find that they don't have SSE, they don't have Neon. However, we do not have enough if defined condition, so they will encounter the compilation error. So we just fix that. And also we fix some warning on the macOS with the LVM 14. And also there are lots of bugs, and I'm not going through all of them. Just if you want to know the details, you can just go through our change log. Okay, so more and more bug fix. Thanks guys for the reporting. And also we still have some known issue, and this is very strange. We are trying to figure out why this will happen again, which is that when you use the universal WASM format on the macOS platform, if you set the optimization level is greater than 0.1, for example, the 0.2, 0.3, then when you try to execute the universal WASM, you will encounter a bus error, and we are still investigating this issue. So just a workaround, if you want to use it, and you have two choices. The first thing is just leave the universal WASM alone. You try to use the the share library extension, so you will directly generate the output of the share library version. You will not generate the universal version, so you can skip this situation. Or you can set the optimization level to 0.0. Just shut down the optimization, and then you will execute normally. And the second issue, very thanks to those people who are trying to build plugin on the macOS platform. They find that in our current design, actually, because we are generating the weak symbol on the plugin mechanism, so actually it will cause the symbol not found issue when do the dynamic linking on the macOS. So we will change the the current plugin design to avoid this. Okay, so there's lots of known issues. We are still trying to fix them. So this is my last slide. So, sorry for a very long presentation, but I want to give a special thanks for all of these contributors with these guys, so we can make this release possible and on time for this project. So thanks for these guys, and that's all of my presentation. Thank you.
All right, thank you, Haidai. Yeah, that's great. So Haidai mentioned there's part of the reasons that we did all those work is we need to support new platforms and new operating systems, especially with AOT, and those are things that you're gonna that we had given a preview last week at the VMware conference, the VMware Explore in San Francisco. For instance, we gave a talk about how to run WasmEdge on the edge, WasmEdge on the edge devices based on RISC-V CPUs, right? That is a very popular choice of CPU architectures today, but for IoT devices. And also we talked about how to run RISC-V at OpenWRT. So I don't know if you guys heard of OpenWRT, but even if you haven't, you probably already have one, because that's the most common Linux operating system that's on your Wi-Fi router, right? If you have a Wi-Fi router, there's a good chance that you already have one in your house. So that's but it also happens to be the edge operating system that VMware uses in their commercial products, right? So we have done a demonstration with using Kubernetes to manage those to manage AI inference workloads, TensorFlow workloads on those devices. That's that's part of the drivers of why we have did those enhancements and those new features as I discussed, right? It's because they are driven by a lot of I'd say real use cases, and we actually have some even more interesting big company collaborations that we hopefully that we can disclose at the next monthly meeting. That's I think there's some truly interesting ones that allows us to integrate into very popular tool chains and things like that. And the other thing you can see is that a lot of those features that we incorporated or we enhanced in this release of WasmEdge has to do with the host function. There's that's indicative of there's lots of activities, use cases around WebAssembly is to embed WebAssembly into another application. So, for instance, that's if you think about the most classic use case of WebAssembly is in the browser. In the browser, it's an embedded use case, right? Then it moves outside of the browser. It finally uses in, say, blockchain as a smart contract runtime. It's also embedded use case because you are embedding it in another piece of software, right? So today we still see a lot of embedded use case, and more and more those host applications want to enhance capabilities in the WebAssembly runtime. So they provide a lot of host, what they call host functions. And so the ability to register and manipulate those host functions has become more and more important for WebAssembly runtimes. And so we are encountering more and more of use cases. So we are providing more capabilities in terms of host functions. And along that lines, we are now, so if anyone in the call is interested, we are working on asynchronous host functions that allows the WebAssembly runtime, the WebAssembly applications to be not blocking in the host environment. So you can start a WebAssembly function, you can pause it, you can resume it. That's so you can do a lot of things that make it more scalable and more friendly in the host environment. So that's something that we are actively working on. We have 3 prototypes using different approaches, all coming from the community, and so it's super interesting, and it's also something WasmEdge users, especially big companies, has been asking for a while. And then on the other side of the coin is that asynchronous functions inside WebAssembly, meaning that's so the typical use case is that say if I want to run a microservice or web server inside WebAssembly, inside WasmEdge, can I do it asynchronously? Meaning that I would have network connections concurrently, although it's a single thread, but but I can have concurrent network connections so that they do not block each other, right? So in that particular use case, it's also as you guys probably recall, that in our what we call WasmEdge WASI socket API, that's our socket API has supported the non-blocking use case for some time. However, it is rather tedious to use. So we have done a Tokio integration. So meaning that we have a slightly modified version of Tokio where you can just you can use the full Tokio syntax in Rust to write your asynchronous or concurrent applications that have them compile into WASM and run in WebAssembly. So those are all really interesting I think use cases where maybe not directly related to the platform, but it's definitely enhancement around the platform. So when we have the next talk, I'm gonna post some links in the chat again about the asynchronous runtime. Let's just talk about. But yeah, but there's lots of excitement going on, and maybe we're gonna cover them in the next talk. But before that, I'd like to introduce Ying He. He's also a co-developer in WasmEdge to talk about some community government issues. That's he would propose new maintainers and committers, and we have a as a sincere project, we have a governance protocol to discuss those candidates and then vote on them in GitHub so that they can be our official contributors. So
hello.
Yes, please.
Okay, can you hear me?
Yes, I can.
Yes.
Okay.
Yes.
Okay, this part is relaxed one. Okay, I'm not so serious one, right? In this section, we introduce the committers and the reviewers of the WasmEdge project. Let me talk about the history of WasmEdge. We started the WasmEdge project about 3 years ago. At the time, there are several Wasm runtimes like JavaScript V8, WasmTime, or WasmEdge. So in the beginning, WasmEdge is a small project, right? We started this project with basic WebAssembly specs and only the interpreter mode. Okay. But when the time going, about 3 years ago, the ahead of time compiler joined WasmEdge. Okay, and we almost completed the WebAssembly basic proposals and passed the official test suite. From then, we started some extensions like you may remember the JavaScript NAPI add-on, right? And about the TensorFlow extension or storage extension or the extension for the Ethereum, eWasm. Okay. About 1.5 years ago, we implemented the WasmEdge C API. So everything started from that because the other programming languages can use the WasmEdge library easily with the WasmEdge C API. So with the C API, we started to have lots of language bindings, such as Go language, Rust, and now we are developing the Python or Java. Yeah. So you can know that in these years, WasmEdge become a larger project with many professional fields, not only the core Wasm runtime written in C++. So, we will cover more language bindings and cover more use cases like the containers, right? And more extension, more plugins. So becoming a CNCF sandbox project about 1 year ago, we started to have more and more contributors. And now I see about 108, right? So we need more and more, we need more committers and reviewers in this project to help us to maintain the quality of the WasmEdge project development. Okay, right? Let me introduce myself first. My name is Ying, right? As a main contributor of the WasmEdge, I'm responsible for the architecture of the WasmEdge internal or the basic the WebAssembly proposals and the WebAssembly interpreter, and cover the tests and even the WasmEdge Go binding and WasmEdge C API and extensions. Okay, so the next one is the next committer is Haidai. Just Haidai is our manager, right? So he will manage WasmEdge like the documentations and the use cases, such as the Kubernetes or C-run, and he will discuss with us about the WasmEdge release progress, such as how many features should we have in the next releases, categorize the main features. Okay. And our next member is Steve. Steve is an LT compiler developer in WasmEdge, and he mainly implement the platform-dependent partitions like in the WASI or file system linking, especially on Mac OS, Windows, even in real-time systems such as EL4. So, and we are refining the plugin system. So Steve do it, right? With the plugin system, developers can create WasmEdge extensions easily in the future. So the many partitions, Steve is responsible for that. And the next one is Sam. Sam is our Rust. Sam responsible for our Rust bindings such as WasmEdge Sys and WasmEdge SDK crates. So he will help us to review and commit the, review and commit the part of Rust bindings. Okay, our next member is DM4. DM4 help us the WasmEdge release on Fedora and the Docker Steam. And our another important feature in the future is we are developing the WebAssembly component model proposal. So DM4 is develop that, and we will support that in the future. And our new member is Danny. Okay, Danny is working on the WebAssembly component model proposal together with DM4. So he and DM4 will maintain the component model proposal part. And another member is E. E is responsible for the WasmEdge CI workflows, with supporting various platforms and architectures. We need a completion CI for testing our codes of WasmEdge, right? So we need E is helpful. E is help us to do to categorize the CI workflows. Another member, our reviewer is Shreyas. Shreya is for the WasmEdge installer. I think everyone use WasmEdge will use the installer to quickly install WasmEdge on your computer. So okay, the installer script is maintained by Shreyas, so he's the reviewer of the WasmEdge installer. Okay, that's it. They're both is the maintainers of the WasmEdge project. Okay, welcome everyone to contribute to WasmEdge. Thank you.
All right. Thank you, Yi. Yeah, that's and that's a really good introduction to everyone that's that's currently making code contributions to the main the WasmEdge project. But of course, we have many as you know, many examples in the satellite projects that we have. We also have maintainers and contributors in those projects as well. So everyone is or really strongly encouraged to to participate in all those projects and nominate people that's you think would be a good fit for for the maintainer role in any of those projects, so to speak, right? That's you can look at all our repositories. Anyway, so yeah, that's all I have on the agenda item for today. So it's 37 minutes, so we may have another 10 minutes left, so if anyone have questions, it's feel free to ask them. Yeah. So I posted a link on the chat, if you haven't, if you're interested, there's it's how to do writing a web server, because one of the common requirements for WasmEdge that people want to use it is to write a microservice, right? In order to write microservice, you need to create a web server that interact with some, in a Kubernetes environment or whatever, right? So that's but that web, like I just said, maybe 10 minutes ago, that's the web server needs to be asynchronous, because otherwise you can only handle one request at a time, and every request is going to block you, right? So it you sort of have to put aside the slow request and then open a new connection and a new one, and that's called non-blocking IO. And we had a way to do that at the socket level, but in reality, nobody does it in a socket level because it's very tedious. It requires a lot of thinking in order to write it properly, and that's why those asynchronous frameworks and asynchronous keywords are invented for languages and language runtimes, right? Like Tokio. So so you can see that in Tokio. However, I don't think we can merge upstream to Tokio at this moment because the WASI networking API, socket API, hasn't been finalized at Bytecode Alliance. So, but for now, I think it's sufficient for us to just fork it and make small changes, and then you can see the the examples that we have. So the link I put in there is a demo for Hyper, which is a very popular HTTP library in Rust. So you can write a server and a client, and you can also have more complex servers like one that does image recognition. You upload a picture and it does tell you what's on the picture through TensorFlow, right? That's so you can have all those and write them in Hyper in very I would say the syntax very comfortable for Rust developers. Compile them into WASI and then run it on the WasmEdge runtime, and then then you have a server, right? You have a web service, and then you can put that web service into a service mesh or anything you want. So yeah, if you're interested, you can check that out. We would have a lot more. As you can imagine, this opens the door for a lot of different things, because once you can have a web service and you can have asynchronous request, you can do, say, database drivers. You can do, just regular web applications, right? So there's lots of things you can do here. And so this is the asynchronous Hyper demo is just, I think, just the beginning for application developers. We are also making this capability available through a Node.js API for JavaScript developers for WasmEdge. So that's you could also write JavaScript applications that is a microservice using Node.js API, but run it inside WebAssembly, right? So that's so there's lots of interesting things. Yeah. So yeah, that's thank you, Brad. Yeah, that's so that's asynchronous support inside WASM. I think make WASM a more complete application server. It's more like JVM this way, right? It's in Java you can always do that, but people complain about WebAssembly to say, you can't even have networking, or you can't write a server in WebAssembly. Now you can, right? And the next step really is to have asynchronous host function support, which I think it's also super interesting, because there's lots of use cases. When you look at when WebAssembly is being embedded in a larger environment, you really need the WebAssembly itself to be non-blocking, and also the function calls that they made to the outside platform to be non-blocking. So when all those are done, I think we would have a much more complete platform for the typical cloud native use cases. So the question asked was, when do we expect Node.js support? So we have a LFX internship. So we have an intern on board. We're onboarding a graduate student that's going to be working on it for I think for the next 3 months. But I hope to be done earlier than that because we are not far away. If you look at the Node.js APIs, I think we are supporting a fair chunk of them. Most noticeably, the networking stuff is already being supported. So you can start a Node.js server today. On WasmEdge already. Asynchronous Node.js server. Of course, the Node.js API has much more than that. So if you just have a random npm package and you want to compile it to you want to run it on WasmEdge, there still may be issues. However, those are just putting the plugging the gaps. There's so we are doing a lot of work in that area, and we are also improving, I think vastly improving the performance of QuickJS runtime inside WasmEdge, because once you have it running inside WasmEdge, there are lots of things you can do. You can start it and then pause it at the startup state. And then when the JavaScript application comes in, you just run the JavaScript application. You do not initialize the QuickJS anymore, right? So there are lots of things that you can do. We are working on those, improving performance. And but for Node.js API support in particular, I think we are targeting November to be completely done. But my assessment is that for many new applications, if you just want to write, say, a microservice in Node.js, you can do it today because most of the networking API is already supported. All right. Any more questions? You can. Oh, okay. Okay, we get this question like, every single meeting. Why do you guys write Wasm runtime in C++? Why don't you do it in, say, Rust? For starters, there's already 2 Rust-based Wasm runtimes out there already, right? Wasmer and WasmTime, and they have both done well. And so for us, Rust is the application language for our developers. We want to support, first using Rust to write WebAssembly applications and run them in WasmEdge, like I just described. Web servers, AI inference, and all that. That's we provide APIs for Rust developers. Second is to embed WasmEdge in Rust applications. If you have a larger Rust application that you need an extension mechanism or you need an embedded runtime, that WasmEdge should be a very good candidate for you. Sorry for the allergy. I'll come back to Austin and have all those pollen allergies. But anyway, so that's so we want to provide the best developer experience for Rust developers. However, for the runtime itself, I think there's many reasons why you want to write it in C++ instead of Rust. There's if you look at I can talk about 2 reasons primarily. The first is WasmEdge called WasmEdge because we want to target a lot of edge devices and the heterogeneous environments that's out there in the in the edge world. That's a much larger context. Is that for the past, I think, 3 decades, the the computing infrastructure has been consolidated to, say, 2 main line of CPUs, the x86 and the ARM. The primary reason is because there's more slow, right? There's a CPU, those 2 major CPUs keep getting better. So, so you are moving more and more computing tasks or workloads through there. However, as those CPUs stop improving, they have been stagnating for a long time. You see more and more specialized CPUs these days. Not CPUs, but GPUs or accelerators and all those hardware devices that are on the edge device. And you also see, because the geopolitical situation in the world, you also see rise of the RISC-V and things, open source CPU architectures. And so I think for the next decade, we're going to see a lot more new hardware and a new operating system on the edge. And they would each be different, and they would each support C and C++ first, because that's the first language you support if you're a hardware or operating system provider, right? So, I think to have a C++ based WASM runtime make it easier for us to be the first to achieve, porting on those platforms. That's also the case that's proven out in those, in the past years, right? We talk about RISC-V, talking about OpenWRT. We talk, in the last year we did Cell4, which is a real-time operating system. It's not even POSIX compliant, and mainly used for autonomous drones and autonomous vehicles, right? So those are things, platforms that we have, need from customers to port WasmEdge to those platforms, right? So those are, I think, the C++ based runtime really help us achieve that. And the second thing really is, if you have, I think for if we are right that WASM would be an important runtime infrastructure in the world in the future, or in the coming years, you would want more diversity in WASM implementations, because if everything is implemented on the same language, on the same libraries, you are affected by the same set of bugs, right? So if there's a zero-day issue that discovered in one of the common libraries everybody use, like log4j, it's a good example, right? That's all the software would have the same issues all at the same time, right? So I'm a big advocate for especially for big companies to hedge their bets. So say something that is standard based, like WASM, that you really should have both WasmEdge and WASM time. Especially used in embedded environments. If they both provide the features that you need, right? Because that allows you to have diversity. One of them fails, you can have another one, right? So it's one of those things that I think has become more and more important as you see more, because right now the primary issues in software security is supply chain attacks, right? We all know that we have heard this term many times, and it's almost, in major open source conference, that's perhaps half of their agenda is to prevent software supply chain attack. Is to say, because it's by far the most cost-effective way to attack, any software system today. Is that through some open source dependencies to slip in some backdoor, and you can do a lot of crazy things with that. And there's many ways to prevent that, but one of the fundamental ways to diversify the base layer of the of the software stack, so that you can have systems running on different layers, and they won't fail at all the same time, or they won't be affected by the same bug all the same time. We have seen this numerous times. So that's but of course, a more controversial reason is that we think C++ does provide better performance, as we can see from a lot of the benchmarks that we did and also we published. Because it allows more optimization, so to speak, right? So it's so that's really the main three reasons. Haidai and Yi, if you have more reasons, you can comment on that. So portability, especially in the heterogeneous environments on the edge that we are facing today, and supply chain security and performance. It's long-winded answer, but but that's almost doesn't matter. From the developer point of view. From the developer point of view, we want to be comfortable in Rust. You're gonna or JavaScript, right? You're gonna write your application in Rust or JavaScript and then deploy it on WasmEdge. It doesn't matter what language WasmEdge is written, right? So by the way, if you look at those Rust-based runtime like WasmTime, time, because we are looking at them, we are learning from them as well, and you will see that some crucial piece of components like their asynchronous host function framework. It's called Autumn Fiber. Is actually written in assembly language, because they need to, have low-level access to the system. So so even for them, it's not, although it looks like it's written in Rust, but it is not entirely in Rust. So that's just a comment I want to make. So we pretty much do the same thing. Yeah. All right. So yeah, I guess that's maybe we can, if there's no additional questions or comments, maybe we can quite a day. And so it's yeah, if you are in Austin and if you want to hang out, I think I'm here this week and I'm home this week, and I'm gonna be in California again next week for the for the big SaaS conference in Bay Area. So if you are in either of those places, drop me a line, through email or through our Discord channel, and I can take you out for coffee, for a meal, that's just we can meet up, right? So that's, I have even met guys from India in this group, right? That's that's so if you're in Austin, definitely come or in the Bay Area, come talk to us, and that's we can meet face to face. Yeah. Oh, so well, I don't know. I was not talking about the. Oh, yes. I was talking about the LFXS internship program. So for the Linux Foundation has a really nice, because we're a member company in the Linux Foundation, and also we're a member project, right? So they have a very nice program that the Linux Foundation pays students to become contributing interns to those to the projects, right? So since we are one of the projects, so we can submit those internship positions. I think it's 4 times a year, so every 3 months, they would have an open proposal. So we would submit some tasks, and the implementing Node.js on WasmEdge is one of the tasks, and also the other one I see Omkar here, and is to implement OpenCV on WasmEdge. Is that because WasmEdge now we have AI inference and all that, but we are missing the part of the computer vision where you pre-process the image, right? So we want to have OpenCV on WasmEdge as well. So that's also an internship task. Over years, we have done a lot of internship tasks, and some, many of them are highly successful. So, for instance, our entire WasmEdge infrastructure is built by a graduate student in China, and so now it supports, say, PyTorch, OpenWino, and not just the TensorFlow. This is also part of the documentation that the development has far exceeded our ability to write it up, right? So that's something we really need to we need to catch up with. So so we continuously getting have those tasks that we propose to the Linux Foundation, and if they approve, they would put out as as an internship topic, and then people all over the world can apply, and that's the amazing thing about Linux Foundation, that they pay interns, and at at what I consider quite competitive salaries, and they can pay almost anybody anywhere in the world, which I also find amazing. That's well, unless you are sanctioned by the U.S. government, but there's very few of those, right? So they can essentially pay anybody. That's in China, in India, in Taiwan, and that's or in other countries, right? That's so we always have those programs, and on a rolling basis, we just closed we just closed one. That's you can go to the ARX Linux Foundation Internship Program website and see our our posted positions. So I think in 3 months of time we would have a new set of positions. But we are we have high expectations of our interns, and we expect them to not making money but also make fame for themselves through this project, right? So that's yeah. Okay, so I think we are at the end of the hour mark, and if there's no more questions, I'll see you next week. From wherever you are, and I don't know where I would be in the next week, but that's a great thing about open source community. All right, thanks. Yeah, bye bye. Yeah.